Okay, guys, so we'll get started. Welcome to the second Tech Talk, predicting Titanic survival rates with Azure Machine Learning Studio. Please save your questions till the end because we're running out of time. We've got about 40 minutes, and then we'll do 50 minutes of questions. So for those of you who haven't met me, my name is Rodney Joyce. I'm a data and AI consultant, and I have a keen interest in machine learning. Okay, so today we're going to look at the Data Science for Dummies series that I keep mentioning. We're going to look at our objective. We're going to do some data science recap. It'll help explain why we're doing the things we do. And then most of the session will be a demo. We'll have questions later. So the last tech talk was on data science overview and introduce you to Databricks, which is a coding solution. This one's going to be no code. So we're going to predict the survival for passengers and then submit it to Kaggle, which I'll go into more detail later. Then we're going to do some data engineering with the Titanic data set using Databricks. Then we're going to use a whole lot of different machine learning tools from different vendors. And the idea here is that we'll compare the accuracy to each other and see which is easier to use and demonstrate all the different pros and cons of each product. And then lastly, we'll end off with a bit of ML ops where we'll look at operationalization of the model and how to get into production, the DevOps for machine learning. Okay, so the objective today is to understand what Azure Machine Learning Studio is, and I keep saying studio with emphasis because there's two very similarly named products in Azure. There's also the Azure Machine Learning Service, which is a completely different product, and I'll show you how to choose between one or the other. And this talk it's not a deep dive. It's basically an introduction into machine learning to show you how easy it is to get started. So I want to focus on the machine learning part and not the data engineering part. And we also look at Kaggle and what's involved there and how to get started there. Okay, so to recap, we've got data coming into a system and we want to get data, we want to get insights out of that system, out of that data, and turn it into actual value. So to do that, we've got to extract our data. We do EDA, exploratory data analysis, where we process the data, prep it, clean it, look for missing values, data munging it's called. We do feature engineering, where we derive new features. We work out which columns are not going to have an influence on our model, and we do visualizations. Then we hand over to the data scientist, who looks at analyzing and modeling, tries different algorithms, and that's an iterative process. And we present it back to the business, and you work out if you've answered the question that was asked. And that whole process is iterative because you'll keep asking questions and getting more value out of it. So today's talk is going to focus mainly on the analyze and model side of things. We're not going to touch the data engineering side of things. So the question might be, why do you want to predict stuff anyway? So on this maturity chart of analytics, you've got things that are really easy to do and the value they provide. So in the bottom left, you've got what happened, which is your operational reporting and traditional BI. So it's kind of static information in the past, not that relevant. Okay, operational reporting. Next up, you've got what just happened. So that's kind of more your real-time dashboards. You can respond to things quicker. Analysis and monitoring of systems in real time adds a lot more value, a little bit harder to do. Then you've got what will happen, which is the predictive analytics, which is what we're doing today. So more complicated to do, but adds a lot more value. And then we've got prescriptive analytics, which is where it's a lot more complex to do, and it's how do you make it happen? So for customers on my site, how can I make him buy the product that I wanted to buy without him knowing it? And that's really the holy grail so far. This will probably change in 10 years, and there'll be another box at the top later. Okay, so Azure Machine Learning Studio, it's a SaaS, which means there's no spinning up of machines, there's no infrastructure, and it's a visual editor. So you can code if you want to. You can drop in a SQL, R, and Python, as you would expect. And it's mainly drag and drop, so even my mother can do it. There's no coding required. There's also notebooks, which are all the rage these days. So it's backed by Jupyter Notebooks, kind of like Databricks notebooks. And it's also got a very easy to deploy model. So if you have a trained model and you want to actually operationalize it, so you want to embed it in an Angular app or embed it in some sort of data workflow, it's very easy to do that. You can turn your model into a REST API, and I'll show you how to do that. Okay, so when would you use ML Studio? So starting from the top left, the first question is, do you have custom or pre-built models? So a pre-built model is where it's like the cognitive services in Azure, where they train the model, like the Face API or Text Analytics or one of those, where you can't change the model, but you can use the results. Object detection, videos, translation services. We're going to do custom models, where we're actually going to tweak the model. So the next question is, do you want to code or do you want to use a visual experience? And we're going to do visual editor, and therefore we're going to use the studio. If we wanted to do the code approach, then we'd use the cloud and we'd use the Azure Machine Learning Service, which is an SDK that we could invoke from Databricks or your Python environment or your Scala environment, whatever environment you're using. But the point is that's a code solution. And you also have the equivalent on-prem. So this is probably the easiest of all the products to get started with, in summary. Okay, so the demo today, we're going to look at Kaggle and download our test and training datasets. We're going to load them into Azure Machine Learning Studio. We're going to train our model on the training dataset. So we know the result in that data, and we're going to evaluate it and see how close our predictions were. Then we're going to submit that to Kaggle, and Kaggle will rank us in its scoreboard out of other tens of thousands of people, and we'll see how good or bad we are. And yeah, now it's time for the demo. Ollie, can you see the Kaggle website on the shared screen?
No. You click the little share thing.
Okay, you should be able to see the Kaggle website now.
Yes.
Okay, so Kaggle is it's nothing to do with Azure Machine Learning Studio. It's a very cool website where businesses or individuals post problems that they have in their business, or just conceptual ideas, hypothetical ideas, and the public can go and try to solve it with whatever tools or frameworks they want. They might set guidelines and say, okay, you can only use this tool, or you can only use these parameters. But for example, Netflix posted their recommendation system and challenged the public to beat it for a $20,000 prize. And someone, basically the public versus their own 3 data scientists, or however many they had, and the public came back and improved the algorithm. So it's quite an awesome idea. The Titanic competition on this website it's free to do. It's a very known domain, so that's why we chose it. It's like we saw in the last tech talk, a lot of the data science and data engineering is all about understanding that data set and how to derive these features and what each field means. Titanic's a very known domain, so I think everyone understands what it is, or they've watched the movie. So there's no ambiguity there. So if we just look at this website,
I just realised you're not showing up on that screen.
But it's recording.
It's recording.
Okay, just hang on a second. I'm just going to switch screens. Okay, so there'll be some information about the particular data science competition. Let's give some background on the domain, and often you might find tips or domain knowledge in this description. And then this is a very ridiculously simple binary classification problem. So it's binary because there's only 2 outcomes. The person either perished or they survived. It's a classification problem because we're categorizing it into 1 of 2 classes. If we're predicting a value, it would be a regression problem. It wouldn't be a binary problem. It says R in Python, but you could use anything in this, whatever you're comfortable with. All they want is the outcome, and I'll tell you exactly in what format it needs to be. So it says predict the survival for each record in the test set must predict a 0 or a 1. Okay, so the metric that they're measuring is accuracy, and there's a whole lot of different metrics that can be measured. But in this case, it's accuracy, and it tells you the format of the file. So it needs to have exactly 418 entries, which is the number of records in the test data set, and needs to have a passenger ID column in any order, and survived, and then a 1 or a 0. Okay, so if we go to the data page, you note that I'm logged in here on Kaggle. We've got training set and test set, and the training set will have the survived column in it. So that's what we're going to train our model on. And the test set doesn't have the survived column. That's what we need to predict. So it's got a very simple data dictionary. So it takes you through all the columns. I'm just going to show you the actual data. It'll be easy to understand. So for example, there's a column called P class, which is the class that the passenger was in, first, second, or third class. So for example, if you think about the Titanic and how big it was, the guys in first class probably had more chance of survival. In those days, it was a much more classist society. That's the kind of domain knowledge I was talking about. Age, the number of siblings they had, the number of parents they had. So the rest of the fields are pretty self-explanatory. So if we look at the training data set, it actually shows you a section of it with a nice distribution. So for example, with class, we've got 3 values, 1, 2, or 3. Most of the people came traveling in third class, and you can explore the data like this. Okay, as you can see, how many were male, how many were female. It's quite interesting. This is what you'd normally do in your your EDA phase, where you start to understand the data. But we're going to skip that today. So I've downloaded these 2 data sets. You can download them both, and I've put them onto a blob over here. So I've got a generation 1 blob. I tried this with Gen 2 and it didn't work. I've got some theories on that, but basically I've got the test and training data set here, and that's what we'll use later. So going back to Azure, we look at Azure Machine Learning Studio. Now, it is free to use for test and development. You can get a paid one inside the Azure portal. So you can just sign up here and you get a free workspace. And I'll just go to the logged in page that I've got open. So basically, the studio consists of projects, which is a collection of assets. So for example, we've got, it's just kind of a grouping of experiments, websites, web services, that kind of thing. Experiments are the main asset in this thing. So this is where we'll do most of our work, and we'll come back here. Web services are how we deploy these models as a REST API. Notebooks are where, if you want to go around and play in a notebook and actually code a bit, you can. If you're going to do that, I would recommend using Databricks or Azure Notebooks or Jupyter, but it does give you the option here. Data sets obviously are like test and train, so I could upload it through the UI as opposed to pulling it off the blob if I wanted to. My trained models, once I've finished training the model, or if a data set was training the model, they could publish it, and then I could come in as a developer and consume it in another part of the workflow. So it allows for different roles to work at this at the same time. Okay, so I'm going to start a new experiment. This UI is a bit old school, but we'll see how it goes. Okay, so it's got like a kind of template. On the left, we've got a whole lot of, they call them modules, and it's all the different things that you might want to do to data. Okay, so for example, first of all, we want to get our data onto this platform. So I'm going to search for the import data module. Okay, so import data module takes in, you can connect to all these different types of things. We're going to use blob storage. I'm just going to go and make a SAS key for this. So I want to get the training data set. And I'll paste the SAS signature. Okay, it's a CSV file, and we're going to say the first row contains the header row. And I know that because that's what Kaggle gave us. We can cache this so it doesn't have to keep going back to the blob each time. And if the data doesn't change often, that's a good strategy. So now we can run. And it's a bit pointless running this now, but I'll just show what it's doing. So obviously there's some VMs in the background being spun up. It's kind of compute on demand, but we're not even paying for this. So now it's going to go and talk to the blob and should hopefully pull this off Okay, so it finished, and we can right click and we can say visualize, and you'll be using this visualize command a lot. So okay, pulled in excuse me, 891 rows. So we'll just go back to Kaggle and confirm that in the training data set there were 891. Yes, there were 891 rows with 12 columns. So let's have a look. 12 columns. We've got passenger ID, survived, class, and we can look at things like let's look at the gender. So you can see it's a string feature, which is interesting. We'll come back to the latter. There's no missing values, and it has 2 unique values, male and female. We can see the subset of the data here. So just for this alone, we get a bit of an understanding of what our data is like. We could compare it to survived. We could do different things that is here. Different kind of plots and graphs. Okay, so the first thing we want to do when we're doing data science is to look at where we've got missing values, and like we saw in the last session, we can either compute those or impute them or remove them or substitute them. There's a lot of different strategies depending on what you're trying to do. For this purpose, we're just going to remove any missing values. We're not focusing on data engineering here. Okay, so in gender, there's no missing values. In survive, which is the label, i.e. the column that we want to predict, there should be no missing values because that'll be pretty pointless if it's a training data set. There's no missing values. Class, there's no missing values. Name, no missing values. Age is missing 177 values, so we're going to have to fix those. The number of siblings they had and the number of parents they had is not missing any values. The ticket is not missing any values. The fare is not missing any values. The cabin's missing 80% of the values. So unless we had domain knowledge to understand where we could infer the cabin from, we're just going to remove that column, not the rows. That's the important thing here. We're not going to remove the rows, we're going to remove the whole column. We don't care about cabin. Embarked is what port they got onto the boat. So I think it's Southampton, Cherbourg, and something else. And it's missing 2 values out of 819. Okay, now another way of looking at your data is using the summarized data module. So we're going to connect the output of the input into there, and we're going to run it again. We just run selected. Even though this is cached, it shouldn't take too long to run. Okay, right click, visualize. Now we're visualizing the results of the summary. So now it's pivoted the values, and it's got the columns down the left, and it shows you kind of summary statistics. How many rows there are? There should be 891 in all of them, except when there's missing data. The missing value count is the one we're interested in. So we can see, as we saw, age and cabin are missing data, and turn and embark. So we'll deal with those 3 columns. The min and the max, there's some interesting stuff here, but we're not going to focus on this at this point in time. So we'll just leave that there. Okay, so to clean the values that are missing, we can use the aptly named clean module, clean missing data. Like I said, even my mother could do this. Thanks to my mother. Okay, so a lot of modules follow the same format here. You use a column selector. So I can choose which columns I want to apply this module to. So we said we're going to clean age and embarked and cabin, but we'll just remove cabin. So let's start doing that now. So let's take age, and we have a lot of, each module's got a whole lot of different parameters to adjust how it works. So for example, we could replace it with the mean value, the median value. We could remove the entire row, remove the column, and each of these is, a deep dive in itself. It's actually incredibly powerful. It's just you need quite a bit of time to understand what it does. So we're just going to say we're going to replace it with the median value of all the other ages, which makes sense. You could do things like split the data by people that were in the same class or with the same title, and try and infer their age. You could do some more fancy stuff with this tool, but that's for more the data engineering side. Okay, so if we run this again, we should see that the age has now been fixed, and no, it won't remove. We still have 891 rows. Now we're going to say let's also what was the other one? It was cabin and so you can't select the columns until it's run the previous module. So run selected. Okay, so we'll have a look at the visualization again. So this was cleaning the age. So we should see for age, we should have no missing values. That's good. And we can even see that the median was 28. So we could tell the output to append a flag to tell us where it replaced a value, and we'll see that those were all 28. Now I'm going to show you a little trick here. For those guys who like SQL, we could do this with R or Python as well. We can actually just run SQL here. So we can say, okay, before I do that, let's just first tell it. We're going to first tell this to append the column. So here we've got generate missing values with indicators. So we're going to tick that, which will add a column called age underscore is missing. So here we can say, if we want to see what it would look like, we could say select star from T1 where age underscore is missing equals 1. And we'll run that again. This SQL transformation will output a data set type as well, but now it should only be filtered by that criteria. So you can see you can do insert statements, you can do update statements. Often if you can't find a module that wants to do the transformation you want, you can just switch to SQL or Python if you're more comfortable with that. So if we look at the results, we should just have 28. So yeah, we've got all the columns where age is missing is 1, and we can see all the ages are 28, which is what we expected. Okay. Now that's just a little tip on how to use the SQL transformation. It's one of the most common modules you'll use. So now we want to clean up the missing data. So we take the output of this one. I'm not going to actually use that data set, but we'll just leave it there. Sure, we'll just delete this. Take the output of this and put it into the input of this. And let's select the columns we want to fix. So we just want to do, the import column had 2 fields missing. Now we could spend a whole lot of time working out what are the ports that they got on with the most probability, but we're just going to actually look at the original data set and see what the most common port was, and just use that just for ease of use. So if we look at embarked, we can see that of the 3 values, Southampton had the most. Therefore, there's a high probability that it's S. So we'll just substitute it with S. It's a bit lazy, but let's do it. So we've selected the column, and we're going to say custom substituted value, and we're just going to replace this with S. Okay, and again, we could tick the ones that were replaced, so we should see 2 records there. I won't run that again. I'll just do some more things first. Now, if we look at the data again, we need categorical features to do data science. We need numerical categorical features. We can't use strings. So passenger ID is an ID of the user. We're not interested in it. We're not going to use it for our model, so we'll ignore that. We're going to drop it out later. Survived is the one we want to predict, the label. Okay, so currently the type is numeric feature. So let's add on something called, if you want to change the metadata of a column, use the edit metadata module. So we bring this into here, and we choose the column. So we want to change the survived feature, and the options of this module are: do you want to change the data type, which we don't? Do you want to make it a categorical or non-categorical feature, which we don't? Or do we want to make it, we're going to say this field is the label. There's only 1 label per data set. There's only 1 thing you want to predict. Okay, and we can rename it if you wanted to. Okay, so if we run that all the way down to here, let's see what it looks now. Okay, so we visualize our new data. So we cleaned up the embarked column. So we should have two records of 891 where embarked is missing as true, and they'll be replaced with S. We could test it if we wanted to. And we changed survived to a label. Remember, it was a numeric field, I think it was. So now it's a numeric label. Okay. And the reason we do that is that there are certain modules that look for the label column in your data set, and they do certain things. So if we mark it as a label, it just infers that for us. We don't have to do extra things. So let's change some more metadata. So we want to change. Let's go look at. We'll filter all the columns by strings. Actually, we've got two binary fields that we're going to discard them anyway. So these strings, we have to do something with them. We have to turn them into categories or non-categories. So, for example, sex is going to be male or female, so that's a category. Name, it's not going to have influence on our prediction. Yeah, we'll just ignore that. Ticket, we're also going to drop that column. It's not really relevant. Cabin, we know we're going to drop. And embarked is three types. Southampton is SQ or C. So we'll also make that categorical. So here we have make categorical. We'll change that and we'll run that. Still running. Okay, so if we visualize it again, if we look at sex, should be a categorical feature. It's no longer a string, which is what we need. And you can test them if you like. Excuse me. The module we use a lot is the select fields module. So this is how we transform data sets into something else. So we're going to say, let's make this a bit bigger. Basically going to say the fields we want moving forward are passenger ID. Actually, passenger ID doesn't matter. We want survived, because when we train our model we need that. Passenger class, name, don't need the gender, the age. We'll keep the number of siblings and parents if it makes a difference. Ticket we're not going to take across. Fare we won't take across. Cabin we're going to drop, and embark we need, and these we won't take across. So basically we're just saying filter out some of these columns. Okay. So let's just run that and have a look at it. Okay, so it's pretty obvious what it should be. So at this point, you could do a summarized data again, check for missing values, check that all your labels were correct, check your categories are all correct, but we'll just go ahead and carry on. So even though Kaggle gave us test and training data, it's not the actual test and training data. That's more something to do with Kaggle. So we need to split our training data into two. We're going to get a percentage that's for training, and then another percentage where we know the outcome for the test to measure that model for efficiency. So we're going to use a split data module, and we're going to take all the 891 rows, and we're going to say split it by a fraction of 0.7. So 70% will be training, and 30% will be your test, or just the random seed in. And this is where it starts to get fun. I won't run this just yet. So it's split at row level. So there were 891 records in our training data set where we know the label. We're going to split that. 70% will be the data that we'll train our model with. And the other 30%, where we still know the label, we'll use to run it through that model and then compare the results to see if it is correct or not. So we use that to evaluate the model. Okay, so let's run this while we do something else. Okay, now choosing our model. There's a very nice chart from Azure, and there's quite a few on the web, but I use this one because it's quite straightforward. So you start in the middle, and it's like, okay, what are you trying to do? We have two outputs to predict. So we go down this way, and if we had more than 100 features, we've got 12 features, which is pretty minimal. We could use this model. If we want fast training, we could use this model. So in our simple example, a lot of these algorithms will work. So we'll just use a two-class logistical regression model to train. If we're predicting values, that's where you'd use a regression ML model. You can't see it here. These are the regression models. So this is how we can understand what are our options. And obviously, data scientists know this by heart and that kind of thing. Okay, so one of the categories here is machine learning. So we've got evaluate, initialize, model, score, and train. So we'll say we want to do classification, and we wanted the two-class statistical regression model. That is here. Okay, so now we're just going to initialize it, and you can see there's a whole lot of parameters that you can enter to affect the way it scores, and that's more the realm of the data scientist. And there's obviously a whole lot of algorithms, and you can write your own algorithms if you really had the inkling to do so. Now, going a little bit into the AutoML side of things is which features are relevant to our prediction here. So there's a nice module called filter-based feature selection. So we could take a guess. It's probably going to be the age of the person, the class of the person. I wouldn't have thought that where they got on makes much difference, but maybe they structured them in certain cabins depending on how they filled the code, so maybe it does. And we're just going to run this again, but it's going to ask us for the type of method we want to use, and there's, again, a whole lot of information you can deep dive in here. And how many features do you want? So let's just say we want 6 features, and we're going to tell it which columns to evaluate. This is which column which is the label column to work out which features affect it. So the label column is survived. And now if we run this, haven't used our model yet. Okay, so we can see the output as usual. Sorry, that's the wrong one. There's two outputs here, as you can see. We're going to look at features visualize. So it's weighted from left to right. So here's the label. Gender had the biggest effect on whether you survived or not. 52% effect or weighting, and you can see how the other fields are rated. So yeah, age I thought was a big indicator, but it's not massive actually, which is quite interesting. And class was another big indicator. So this could automatically, if you had a data set with 200 features or 1,000 features, or you're making up features on the spot, this can help you work out the ones that have the biggest effect. So I'll just put that to the side. Let's go back to our machine learning stuff. We've chosen our model. We now want to say we actually want to train the model. So we use a train model module, and this takes in one of the types of algorithms that we selected, and it takes in the 70% of data that's our training data. Okay, the output of this we're going to score. So we'll get the score model, and we'll take the output of that and put it onto the input of that one, and then we need the other side of the split data, which is the 30% where we know the outcome of the label goes onto the input of that. Okay. Now, if we run this, it wants some more information. It wants the select tool to make a selection, and it wants to know the label column, which is survived. So it needs to know what it's predicting, obviously. So you can see I'm running a branch here, so it just goes a little bit quicker. Run selected. sorry. Okay, so that finished, and let's look at the output of train model. So that shows the weightings that we looked at. Now this is really interesting. When we did our Databricks talk the last time, we used one, okay, I don't think we actually got to it, but we were going to use one hot encoding when we got to the machine learning part. So if you've got male and female and they're strings, you can't just pass it in. You have to say, you have to encode it. So we can use one hot encoding where it takes all the possible values, in which case only two in gender in this situation. And it's going to say, let's say for one record it's got, it's a male, then is male will be 1 and is female will be false. It will be 0 for that record. If it was a female, then is male will be 0 and is female will be 1. If there were 3 options, you'd get this situation where you've got embarked S2, embarked C0, and embarked Q1. What I'm trying to show you is that they've automatically done one hot encoding on our data set. We didn't have to do it. Whereas if we're using the coding way, we'd have to do one hot encoding. Vectorize our fields, our categories. Okay, so we did the modeling, and now we're going to see the result of the score module. So it's added two more columns. The result, which is a 0 or a 1, and the probability of it being correct. So it's 56% sure that this person perished. Okay, now we have to evaluate it. So we're going to use evaluate model, and this gives us more information about how accurate this was, so we can get the precision, the accuracy. Okay, so this is a rock curve, and it's basically showing where the intersection of the results are. So I'm not going to go into too much detail here because there's a lot of theory behind this. You can see there's a lot of information. You can also bring in this evaluate module takes another thing, so another input. So we could put another model here and put the output of that into the input here and compare the two results. So we get a confusion matrix here, which is basically true positive is how many times it thought that the label was 1 and then it was right. True negative is how many times it thought the label was 0 and it was right. False negative is how many times it thought it was 0 and it was wrong. And false positive is how many times it thought it was 1 and it was wrong. So obviously the 100% would be 0 over here and 0 over here, right? No falses. But there's all different ways to calculate precision, recall, and F1 score and accuracy based on the confusion matrix. But we're not going to go into that. That's for another tech talk. So what we're interested in here is the accuracy. There's a 79% accuracy here, which could be okay. It depends on your business. That could be okay. Okay, so now we've trained the model. It's giving output. We've got a few options here. First thing I'm going to do, I'm going to save it as a new experiment. And I call it CleanXP. And I'm going to remove all this, these extra debugging things that we put in. So it's very streamlined. This is like the most basic pipeline you'll get. And I have to run it again just to let you make changes. What we're going to do after this is we're going to basically create a predictive web service, a predictive experiment. So in this one, it's training. We want to convert it into a predictive one where we can pass in our Kaggle test data set. Okay, so we're going to turn this into a predictive web service. Okay, so it's given us a tabbed interface here. You can see the old one and the new one. And it's done a few fancy things here. It's now put in a web service input. So that would be, you can either pass in data from a REST API or you can use import data. So import data is still looking at our training data set. We're going to get rid of that, and we're going to take in the test data set from Kaggle. I've got it on a blob, but I've also got it saved, so I'm just going to bring it on here and pass it in here. Cannot connect to CSV. Okay, let me do it the long way. Bob. So we need the import data. We're going to use another SAS key, and we're going to get the the test. Just get a shared access signature for read. It's a CSV file, and it's got the header row. Is that not working? Sorry, I'm going to the wrong side. Silly, stupid user error. Okay, so you can see it's taken all our modules and transformations in the training experiment, and it's turned them into compiled transformations. So we no longer get the same module names. It's basically it's all compiled, and it'll do the same thing. However, now we don't have the survived column here, so we're not passing it in anymore because we don't have survived from the test data set. So we're going to look for wherever we mention the survived column and take it out. So here remember we said that survived was the label. That no longer applies here because there's no label anymore. We're not training. So we're just going to delete that. We also said that still applies. And then we've got to make sure we don't have survived here. Everything else remains. And I think that should be about right. So as you'll notice, we're not training anymore. We're just scoring. There's no training. And let's try run that and see what happens. So there's two different outcomes we want here. One is that we want to take the test data set from Kaggle and run it through and submit that to Kaggle. The other thing we want to do is publish this as a REST API web service where we can pass in those input parameters manually or from an API and get a response back. So we're going to do both of those. Okay, so it finished. Let's have a look at the output. Okay, so we've got predictions. It still thinks we got 891, which is incorrect. I think I must have pasted the wrong data set. Let's do it again. So we want the test data set. To make sure it's got the right data. So there should be 11 columns in this one, not 12 columns. We actually do want to cache it as well. Okay, so that's better. 480 rows and 11 columns. Okay, let's try run that again. Okay, well, we've got some time while that runs, so I'll just talk about the Azure Machine Learning service for a second. So fairly new, but Azure Machine Learning Service is a service in Azure where you've got experiments and deployments, and use an SDK to interact with it, or an API, and it will basically keep all your experiments and you can compare the values of them. It's also got this to a degree, so I actually think that Azure will deprecate this in the next year or so, because it's quite confusing what they've done here. But because they've got this in the other service, I think this will eventually disappear. Okay, so let's have a look at this output here. Okay, so we've got some predictions on our 418. Now, to output this to Kaggle, we need to get the passenger ID. All they want is the passenger ID and the label. So before we do that, let's deploy this as a REST API. So you can imagine if we were using or doing this manually, we'd have to Dockerize our model somehow. We'd have to put an API on top of it. This does it all for you. So it's probably doing that behind the scenes. Definitely on the Azure Machine Learning service, you can run AKS, you can run Docker containers on container registry. But in this one, it's kind of hidden through. So it gives you a nice test harness. It's really beginner friendly, so you can click on View in Studio and it will open up the SDK with the code all written with the parameters. So that's all the information. So if we pass in all the stuff, so passenger ID doesn't really matter. Let's use Rory as an example. Unfortunately, he's not here, so he's not going to see this. So Rory's coming from Ireland to seek his fortune. He's male. I don't know, he's 32. He's got 10 brothers from Ireland, 2 parents, and he stole his ticket. And he's down in the dungeon somewhere, this dungeon, and he got on at Southampton. We'll see if he would have survived or not. Okay, so here's a goner. Whereas, let's say I was traveling and I was traveling first class. I'm 35. Traveling alone, and yes, I survived. Rory didn't. Unlucky. Okay, so that's given us a very simple test harness. It's got the Swagger API, so any tool that uses Swagger could use this to reverse engineer your SDK stuff. It's pretty impressive what it gives you out of the box. It's got a dashboard, it's got analytics, everything. Okay, so actually one more thing I'll show you. If you were going to consume it, you can use it. You can even use Excel to use it as a test harness. You get an API key. It gives you the C# code to actually consume it. Python code. It's really impressive. Very easy to get started. So you can see how you could just wrap this in an Angular app and pass it the parameters, or insurance application, whatever you were using. Anyway, okay, so going back to our experiment, we're now going to submit this to Kaggle. So I'll go back in here, and if we look at our output again, let's see what we've got. Okay, we don't have passenger ID. That could be a problem, and we've got scored labels, which needs to be called survived. So let's we're going to use edit metadata. I'm going to take the output of this, and we're going to say change the name of the scored label thing to be survived. Now you could also use a SQL module and do a select as start or select as whatever as alias, and change it like that. There's many ways to do things here. And now we need to select columns. And we just want those 2 fields, which we don't have one of them, which I'm trying to think how we're going to do that. Okay, so we need passenger ID, but we removed it over here somewhere. So Yes, so over here we took it out. So let's add that in. And then it should come out of the model, and which means we could select it here. Okay, it's saying it's pink because it hasn't run before, so it doesn't realize that the module above has renamed it. So let's just run down here. Okay, I'll just double check. We logged into Kaggle. We're going to go to submit predictions, and you get 10 submissions a day. So you have to upload the file, and you can track it or whatever you want to call it. So this would be a kind of 2-class statistical regression with very little data engineering. Okay, so we're just going to have to do one more thing. So yeah, we've got passenger ID, 480 columns, and sorry, all right. It should have survived now. Yep. Okay, run selected again. Just run the last thing. Now this is outputting a type of data set, which is a type native to this program. So we can't download it, we can visualize it. Okay, so we've got predictions and we've got ID, that's good. We could save the data set. So this is where I might hand over to someone else and say, okay, this is called Titanic Kaggle results 1. And then you could go and do another experiment with that from that starting point. So it's pretty powerful. You can also save this model as XYZ, save your transformations. But we want to output it. So I'm going to do convert to CSV. And run selected. And with that, we should be able to download a CSV file and submit it. Okay, download. Okay, so I flick over to Kaggle. We drag this file up into here. Okay. Now this is where it would tell you if your schema was wrong, if anything was wrong, it would tell you here. So hopefully we got it all right. Don't expect miracles here. There's a lot of smart people doing really smart data science here. Okay, so our score was 0.75 accuracy. And we'll go to our scoreboard. So we're number 7,900 out of, I don't know how many thousands there are. There's quite a few thousands. But yeah, so I mean, this is the hello world. So everyone's doing this, and it keeps resetting the scoreboard. But the idea is here that you would then go back to your model, you would tweak it, try different algorithms. There's a whole heap of stuff I haven't showed you. I'll talk about that in a second. So okay, we submitted that. So let me flick back to the presentation. Okay, so we operationalized our model. Okay, so the key takeaways here. It's really easy, it's drag and drop. If you don't want to code, you want to focus on the bigger picture stuff, this is a great way of getting into it. Kaggle's pretty cool too. They've got lots of training courses, Python with data science, you know, starting from beginner level all the way to advanced. So when you start going into the data munging process where there's all different libraries for visualization and statistics, that's where it starts to get more advanced. So to improve our accuracy, what can we do here to go up on the scoreboard? Trying all the different algorithms would be one way. Doing it feature engineering will be another way. So we did that in the last session. We inferred the title based on the name. We guessed the age more accurately than just the median. All of those things might or might not improve our accuracy. So that's what we could try. We could do different experiments. What else could we do? Yeah, researching the actual incident itself and looking at to see if there's additional information that we could join with to infer. Maybe you could get weather patterns, or there's some creative things you could do. Okay, there's some links there to get started, and that's all. So, are there any questions on anything we saw today from the room or online?
Those models you got in, but it's just like Kaggle's AutoML. Like, how does that compare to something like Google's AutoML?
Okay, so Ollie asked the models I bought and all that. Is it like AutoML, and how does that compare? So that's not actually AutoML. Those are the canned models, whereas AutoML would be the SDK would try all the different possible models there are, and then all the different possible features and all the different possible parameters, and choose the right mix. So we'll do AutoML in the next session with Azure Machine Learning Service. This can't do AutoML. There's one thing it can do where you've got hyper-tuning parameters, where you've got a model that requires parameters. You put this module in first, and it will go and try everything it can. So that's a form of AutoML. The other thing it's got is cross-validation filtering. So we just picked 0.7% of our split. Whereas if we use this thing, it would make a whole lot of different groups, different splits, and validate that it is actually, it'll keep tweaking against it and keep retraining our model. So we only trained once, which is ridiculous. We should be training a whole stack of times. But AutoML is very cool. So you can see number 6 is machine learning service in AutoML. And that's exactly what I want to compare. How does it compare to Google's and SageMaker and things like that in AWS? Any other questions, Praveen? No?
Is ML Studio in...
One question per person, please. No, Jackie.
You have a question? I was just wondering if it's available in Australia.
It's not actually. So I'm pretty sure it's going to get deprecated. It's been out. It was the first thing to come out like 4 years ago, and it's not in Australia. And the fact that this UI, 90% of it's in Azure Machine Learning Service, which is so much more powerful, I think this will just get the chop at some point. But Azure Machine Learning Service is, I'm pretty sure it's in Australia.
Machine Learning Service is also free. Can use it for
service? Yes. It's not free. You can do this kind of stuff for free. You have to choose a compute engine. So you can use data science VMs. You can use Databricks as your compute engine. Or you can use its VMs that it recommends. Like once again, I burned through all my credits. I seem to make a habit of this. Luckily, I had the switch off limit at $200. So I deployed to AKS, Kubernetes, and it failed. But it created the whole Kubernetes infrastructure. So it had VMs, it had container registries, it had everything. But it didn't actually, it said it failed. And I had 3 clusters running without me knowing, and it chewed up my credit in a day. So this is definitely better to get started with, and then switch to Azure Machine Learning Service when you want to start coding more. Good question, though. Any other questions, Ollie, online, or? You've got my LinkedIn on the top there, so if you have any questions or want to chat about something, let me know. It's pretty fun, this stuff.
Any other questions?
Okay, thanks, guys. Cool.